İyi akşamlar. Yine Mimarlık Festivali'nin keynote konuşmalarından sonuncusuna hoş geldin. I'm going to continue in English. I hope that it is okay. So you have in front of you Peter Clegg, who is sitting somewhere near London, or is it near Bath?
Bath.
Bath. Yeah. So on the west, near the west coast of England, it's a garden shed in his small office where he works from at the moment. Like all of us, he's also working remotely. And thank you very much for joining us, Peter. This is not your first time in Turkey. It's probably the fifth time, or I can't remember now, but it's been a few times. I think you've been coming and going to Istanbul a number of times. Just to briefly introduce you to you what we're going to talk about, or what Peter is going to talk about. His main emphasis is going to be on, at the beginning, on the the issue of low carbon architecture and how our understanding of low carbon architecture has developed in the last 10 years. The subtext of this is beyond declarations. I don't know if everybody is familiar, but in the last year, since the, I think I'm right in saying that it's the Swedish young lady who started this all. What's her name again?
Greta Thunberg.
Greta Thunberg.
Greta Thunberg.
Greta Thunberg, when she started to sit in front of the Parliament House protesting carbon emissions and protesting how us adults are not taking any notice of the reality of the situation, it grew into a whole process of protests all over the world. And in the UK, a movement started called Architects Declare, of which Peter Clegg, Feilden Clegg, amongst many other practices, Peter, you will count these, actually set up the first chapter of the Architects Declare organization. And Peter will go into that, but this is a kind of protest. It's a protest by architects, rather like Greta Thunberg, saying enough is enough, let us all do something about that. Let us all do something about climate change and put our names to it, sign our names to it. The question is, what happens next? After you signed your name to it, what happens next? And Peter is going to discuss that with us, I hope, which I'm waiting for with great interest. And the second part will be more about educational buildings as your work relates to climate change and how it's applied in the design and execution of buildings. And I think you'll show us 3 or 4 of your recent projects, award-winning projects, which we're all looking forward to. Just a very quick word about Feilden Clegg Bradley Studios. Now, Feilden Clegg, actually, Feilden Clegg Architects was the original name of the practice. Actually, I should go back even further. It was called the Architecture Shop. Yani Mimarlık Dükkanı diye bir ofis açmışlardı. I'm sorry, I kind of occasionally go into Turkish for everybody's purpose. So the Architecture Shop first started in 1978 in Bath, right across the road from where I lived, where I worked as a stagiaire. It's later evolved in, and it actually specialized at that time in community architecture. That was its strong selling point. And obviously energy efficient architecture, ecological approach to design, and so on. The practice then dropped the name Architecture Shop and became Feilden Clegg Design Architects, and subsequently Richard unfortunately passed away after a very sad accident, and Keith Bradley also became a partner, and the name is now Feilden Clegg Bradley Studios. Peter is a professor. He teaches in many universities, but he's a professor of architecture at Bath University, and he's taught in a number of universities, but graduated from Cambridge, I believe. And I think that's about enough, isn't it? CV stuff. we'll let you take it away, Peter. We're going to, as I told you before, interrupt you every now and then, and there will be questions. Hopefully there will be questions. Sorularınızı lütfen sormaktan çekinmeyin. Süreç içerisinde sorularınızı iletin. Bizim tarafımızdan sorular Peter'a eğer zamanı gelirse yönlendirilecek ve bir diyalog halinde devam edeceğiz. Yani Peter'la bir sunum sırasında bir diyalog kuracağız. Take it away, Peter. Thank you.
Thank you. So, can you hear me and can you see my screen? Just checking.
Yes.
Yes.
Fine, okay. So, yes, so Selçuk has given you the history of the practice, so I don't need to do that. He has. I should explain to you that Selçuk was our first employee. So we learned a lot from Selçuk, and I hope he learned a lot from us. But it's been great, maintaining this relationship over about 40 years nearly. And where I note that you're saying that you're going to interrupt me every now and then, Selçuk. All I would say is I'm used to it. I'm used to being interrupted by you. It was the thing I remember quite a lot when you first came to work for us. You were always very good at interrupting. Okay, so I am going to give a talk which is focused around low carbon design and our new understanding of low carbon architecture. And if I can remember how to make this work. Essentially, what we're talking about, this is a game of choose your crisis, really. Choose your crisis. Biodiversity crisis was, we're losing 1 million species. We're in danger of losing 1 million species in the next 10 years of the total of our biodiversity. This is a beautiful animal called a pangolin, and we slaughter to 2.7 million of those every year for Chinese medicine. It's just really sad, but there's huge amounts we're treating the world and the world's occupants really badly. And we're treating the climate very badly by putting too much carbon dioxide and greenhouse gas emissions up into the climate. And as a result of that, both of those crises, we have a third crisis, which appears to be at the moment the most significant one, but is actually far less significant than the first two. And we have been, as Selçuk said, we've been designing low carbon and particularly sort of low operational energy buildings for the last 30, 40 years, but actually everything has changed in the last 2 or 3 years. And what has changed is the IPBS global report in 2018-19, the UN report on biodiversity was full of shocking statistics. We are in effect in the 6th major extinction in 450 million years. So this is akin to when the dinosaurs were died out, and there are no more dinosaurs left in the world. We know that. And God knows how many of us will be left in the world and how many species will be left in the world. But the rate of extinction is similar to that during the dinosaur era. And we are, as we know, this is a shocking report that came out a year and a half ago, that said that we should actually be looking at, we had only 10, 12 years left to think about reducing carbon emissions before we hit that tipping point of global warming of 1.5 degrees centigrade, beyond which the melted ice caps would send us into a spiral of temperature rise. And as Selçuk has said, I think a lot of the change that came about through Greta Thunberg, through Extinction Rebellion, which is the kind of out on the streets radical movement that was highlighted a lot of the summer of 2019 in the UK. And I don't know whether you were there, but on the 20th of September, there were 7 million people in 175 countries took to the streets to point out our failure to deal with climate change. And we had been dealing with it for 40 years, but we recognized that we had failed to deal with it. At the other end of the spectrum, in the UK, we have someone called David Attenborough, who you may have heard of, I don't know, but he's a 95-year-old. So we have a 15-year-old and a 95-year-old that are really telling us what we're doing wrong with the world, both in terms of climate and in terms of biodiversity. And he's produced the most amazing film called A Life on Our Planet. Do watch it if you can. It's out on Netflix. And this image is an image of Chernobyl, right? So this is an acknowledged failure of modern technology. Chernobyl, the disaster of a nuclear power plant in the Ukraine. And you go back there, he goes back there and he shows you that actually nature is taking over. After 25 years, nature has got the upper hand again. And it does show you that there is the capacity of the earth to regenerate itself, whereas we as humans have the capacity really to destroy things. Now, this won't be too technical. I'll get through this fairly quickly, but just to show you some data, annual carbon dioxide emissions by world region. And it all started obviously the beginning of the Industrial Revolution, 1800, 1850, when we started digging up carbon out of the ground in the form of coal and then oil and then gas. And it gave us, those of us in the global north, it gave us a better standard of living, arguably. And we started pumping out carbon into the atmosphere. And this tells you here, if you look at what's happened, the bottom color there is the EU, 28 EU countries. And you look at that and you think, oh, well, we're maybe after all these decades of ruining the world, we're getting better we're reducing our carbon emissions. We have reduced them since 1990. But then what we're doing that because we are importing all the stuff that we import from China, which is dealing with, which is where we have exported our carbon emissions in a sense. Mm-hmm. And what we have to do is do that with these carbon emissions. That's what the UN, that's what virtually everybody agrees we have to do to get to zero carbon by 2050, which is a shocking reversal of where we are now. And then we start thinking, as these declarations came about in the UN, in the UK government, European governments, all the way around the local authorities in the UK, we ended up with wondering about, well, what can we do? And you suddenly realize that actually, as architects, we're responsible for more than 40% of global carbon dioxide emissions. And so most of that is currently in building operations, but 11% of it goes into construction and materials. So I was contacted by a friend of mine called Steve Tompkins, who Selçuk also knows, a graduate of Bath University. So I taught Steve as I taught Selçuk. And Steve had just won the Sterling Prize for a beautiful building in Liverpool, refurbishment of a theatre building. And we got together and he suggested, well, why don't we get all the Sterling Prize winners that are alive from over the last 20 years or so to sign a declaration saying architects need to put their house in order, need to actually change the way they operate. And we got the South's 17 founder members, which includes Foster and Chipperfield and Zaha and Rogers and all the English-based architects that you've heard of, and many that you probably haven't. And we put out this declaration, which then grew over a year to 1,000 practices. And we started with just architects, and the engineers followed, and landscape designers followed, the architectural educators followed, and we also through the emergency declarations and through the out on the streets, this is us out on the streets in London, there was a huge amount of publicity for the cause, and we're still growing. We now have about 1,060 architectural practices in the UK signed up, but more importantly, we've become a global movement. So there are 27 countries there. I note that Turkey isn't amongst them, but I'm sure it will be shortly.
Turkey will be joining very shortly.
We've been talking about that, haven't we, Selçuk?
Yes.
So I think it is a really, it's very easy thing to do. It's too easy to do. It's very easy to sign a piece of paper, isn't it? That's something we'll be coming back to later. But we've also looked in the UK, at least, towards creating a bigger umbrella body called Construction Declares, and that we've now got project delivery people, and we've got contractors joining us, architects, engineers, and landscape designers. And we're also looking at regional groups as well to keep the debate front and center of everything we do. So I'm not going to go into the details of the declaration, but it's not much more than this. It's 11 points. I don't know whether you saw that movie Spinal Tap, where the guy has his he has a guitar with an amplifier that goes up to 11, and he's always very proud of that because it's much better than if you just go up to 10. Anyway, so we have 11 points in our declaration. Just to touch on a few of them, the most important thing is to raise awareness of it with our clients, with governments, with regulators. We think it's really important to share knowledge and research and performance data on an open source basis, understanding how our buildings perform. We are seeing much more in the UK now, and my practice is much more focused on upgrading existing buildings, refurbishment, and thinking about a more carbon efficient alternatives to new buildings, and accelerating the shift to low embodied carbon materials in everything that we do. And this is, I think, the major change for my practice over the last few years, is that we're now much more focused on materials rather than operational carbon, which it's still very important. How we light and heat and ventilate our buildings is really important. But if you look at the statistics, as I'll show you, it's the embodied carbon, the stuff we make our buildings of, is as important, if not more so. And we have to go full circle, and we have to think just doing sustainable design is not good enough, really. We need to think about more. We think about regenerative design, taking over brownfield sites, for instance, and making them into centers which are based on biodiversity, introducing new biodiversity, but also introducing buildings that potentially don't use carbon, but perhaps generate carbon because of the use of solar energy and photovoltaics on site. So that's a sample of some of the declaration points. But essentially what we're talking about is a transformed built environment, planned and constructed and operated within planetary boundaries, delivering positive social impacts for all. And if you extend that globally, of course, you find that there are countries in the global south where actually the basis of human health and education is not met by the standards of living that exist there. And if you look at the global north, what is happening is that we have an outrageously absurd lifestyle, which actually means that we are breaking through planetary boundaries in terms of CO2 pollution, in terms of air pollution, in terms of water pollution, in terms of all kinds of sectors where we are damaging the environment. And so somewhere between the outer rim of the planet, of being kind to the planet, and the inner rim of ensuring everybody's social and health needs are met, is a sweet space that we're aiming for. So just very briefly, too many figures here, I know, but just to let you know that the RIBA in England, the Royal Institute of British Architects, have set climate challenge target metrics for domestic buildings, non-domestic buildings. It's interesting because our legislative framework is way out of date. And we tend to rely on things like BREEAM and LEED, which I regard as way out of date, because there are all kinds of ways you can fudge those systems. And the most important thing is to actually go for base data on embodied carbon and operational carbon. And these two guides, I'm just putting that there because they came out last year, and they are written by young professionals in the engineering and architectural practice. Selçuk, you want to interrupt me?
I thought I would start early.
Go ahead.
Many people don't understand the difference between operational
Okay.
carbon and embodied carbon. If you can be literal in explaining it,
Yes.
just for a moment, I think it will be very useful.
Okay, it's fairly straightforward. Well, here you are, exactly the right time you made that interruption. My next slide. So this is a relatively simple diagram. You see at the bottom the building life cycle from practical completion, when the building is finished on site, to the end of life when it is demolished, right? And practical when it is practically complete, you can see there is a huge amount of embodied carbon that has gone into it because of all the materials, all the transport of those materials to site, and the process of construction is huge. Then you look at the building life cycle, and here we've got a 60-year life cycle. And in the yellow there, you can see over every year, this building is using energy. It's using energy for heat, for ventilation, for lighting, and for power. And that is typically the operational energy of the building. So the operational energy is what's used every year to keep the building comfortable, habitable, etc. But then you'll see there's little pink slips that come up every now and then where it says replacement and maintenance, because no building is going to last for 60 years without having, for instance, new glazing, or generally after 30 years, a new MEC, mechanical systems, etc. So what you have to think about is the whole life carbon of the building, starting with an enormous input into constructing it, smaller inputs into keeping it going, and then at irregular intervals throughout its life, it's going to go through maintenance cycles. And at the end of life, there is a cost of disposing of it as well. Is that as clear? I hope that's clear.
Yes, just can I translate it into Turkish very quickly? Bu
Yeah.
Practical completion deyimi, yani binanın teslimi. Binanın tesliminde binanın yapımı için harcanan enerji, embodied carbon, bütün malzemelerin içine gömülmüş ve bütün proses tarafından üretilmiş, harcanan bütün effortun karbon emisyonu, bu practical completion emisyonu, yani kırmızılar. Kırmızılar yapısal, turuncular da operasyonel, yani binanın ısıtması, soğutması, yönetimi vesaire. That's it.
Okay, great. So that's that. And this, just for information, just for out of interest, is where the embodied carbon goes into all those materials. It gives you an idea of the percentage of embodied carbon in a typical building. And so much of it goes into the frame and the foundations, followed by the envelope and the upper floors and the foundations, then the envelope and the frame and the piling. Huge amounts of that goes into the construction of the frame of the building, and then all the internal walls, ceiling finishes, etc., much smaller amounts. So I'm going to go through this very quickly because this, if you're interested in this, then go to our website and you'll be able to download it and get more information on it. But we've produced Carbon, FCBS Carbon, which is a tool for estimating whole life carbon right at the outset of a project, right? So we look at the operational carbon. Here you see the space heating, water heating, etc., and all the electrical energy and non-electrical energy that goes into it. And we can, if you haven't got the data, you can use those figures at the top that are guesstimates as to how much that would be. So this is, and then the embodied carbon side, as I said, is determined by the form of the building. So you can fill in when you just have a sketch design, building perimeter, building footprint, building width, floor to floor height, number of stories, glazing ratio, and you will get a figure out of this system for embodied carbon. And you can look at putting more detailed data in if you wish, but the output of the system is just these four, which give you top left, operational energy, and this is in electrical and non-electrical, but total energy. It'll give you embodied carbon, which is the carbon that goes into the building on the top right. It'll give you whole life carbon, looking at a 60-year life, bottom left. And it will give you the amount of offsetting that you may need to do if your building is not zero carbon. So it's a very simple for people, someone who can fill in this data in half a day if you've got an outline of a building design at stage 1, stage 2 of the process. And just to look at these in a little bit more detail, then this gives you the top line there is how where you stand on the RIBA scale, what they call the 2030 challenge. If you're in the green sections, you're good. If you're in the red sections, you're bad. So it immediately tells you where you are. And then the same with the embodied carbon, the carbon that goes into the materials, and the whole life carbon, how it's building up over in fact, here, a 120-year lifetime, and what the sequestered carbon that you might need to, what you'd have to do in order to account for the fact that your building is going to end up using carbon over its lifetime. And you can sequester carbon by planting trees, soaking up carbon, or by donating to funds like climate care, or like the local authorities and local governments in this country have funds that you can donate to that go into insulating buildings. So I'll just put that out there, and I'll just show you very briefly how it works. This is a simple building that we designed about 3 years ago. It's called the Woodland Trust Building. So you need you need less than this data, really. This is the footprints. This is just happens to be the images of the building. It was an entirely timber building here, cross-laminated timber and timber and wood wool insulation, timber cladding. And this is the data that you get for that building. But this is data that we actually have gleaned from the real building in terms of the operational energy. And you can see it's not working very well at all. It's way off the end of the scale. And that's because it has a huge server in it. It's controlling masses. It's got a massive computer in it. If you take that computer out, then it's not doing, it's doing pretty well. In terms of embodied carbon, the top left-hand side, you can see it's doing incredibly well because it's all made out of timber. Anyway, and then we just did an exercise to how to make it really super energy efficient by putting in an air source heat pump and putting in photovoltaics. So you can use this tool also to compare different strategies.
Peter.
Okay,
Yeah.
Go ahead, because I finished the first bit. I finished the technical bit, Selçuk. Some of you will be glad to know.
I'm okay with the technical bit, but your screen is frozen a little bit, so your image is in frozen motion. I don't know whether that can change. Maalesef Peter'ın bilgisayarında bir donma oldu. Onu yeniden başlatması gerekiyor. Kusura bakmayın. Ama oluyor böyle şeyler. Teknolojiye muhtacız bu sıralar. Bu arada isterseniz diyaloğu devam ettirmek amacıyla sizlerden sorular varsa, Peter'ın şu ana kadar anlattığı şeyler konusunda sorular varsa buradan chatten sorabilirsiniz. Ve 1-2 dakika sonra Peter bize katılacak. Ece, what do you think so far of what Peter has said? It's an interesting continuation from the white architects presentation the other day, isn't it? Where they're talking about timber in architecture, which zeroes the carbon in a building from the very start. Yani bina daha yapılmadan sıfır karbon harcamış oluyorlar malzemeden dolayı. Peter'da
şöyle karşılaştırmak gerekirse Peter Clegg, Clegg Feilden Bradley Studios daha enerji hesaplamasıyla düşük karbonlu binalar tasarlama geçmişinden geliyorlar. Sizler de öyle. Evet. Ve onun karbon emisyonlarını hesaplama devresine geçen, kendilerini o şekilde yenileyen bir ofis. Yani İngiltere'deki bu daha geleneksel enerji hesaplamalarından karbon hesaplamalarına geçiyor. Bence White Architect'ler buradan başladıkları için. He's back.
Yeah. Peter is back.
So it's interesting to hear this comparison, really, their transmission.
Peter, you're back. Are you okay?
I'm back. I'm fine. I'm very sorry about that.
That's okay. We were just saying to Ece and I were just saying how interesting that your office is actually creating a what relatively technical document through an architect. The Excel model that you've created is relatively technical. And I was going to ask the question, is that a model that you as architects alone can utilize, or do you need an input from engineers along?
No, you can. There is detailed information that you could bring from an engineering practice if you had that. If you had an engineer with you, if you want to make the shortcuts and make the assumptions, for instance, about the lighting loads and heating loads, it will give you some default figures to use, which are typical for the type of building. Yeah. So you don't need that technical information, and you don't need any information about the density of materials, the carbon content of materials. All of that is built into the database that runs the Excel sheets.
Yeah. So any one of us can actually download that from your.
What we we would love you to download it, and we would love you to explore it and to tell us what works and what doesn't. We're not promising that it is completely infallible. It's been we have been using it only 6 months, and we've been gradually improving it. It's constantly being worked on by an engineer and an architect in my practice working together. We think it's a very useful tool for early stage design work. It doesn't give you extraordinarily reliable data right the way through the process at all, but to get an early indication of both operational energy and embodied carbon, it's very, very useful, we think.
Very nice of you to offer that as a free software. I mean, can I ask you a little bit about how the office works in that sense? Do you also have a research department, in inverted commas? Do you have a research process going on in a dedicated way, or does it happen as a part of projects and so on? Do you have someone?
We have someone who coordinates the research in the practice. Someone who Ian Taylor, who is a senior person, who is a research professor at UCL in London, as well as a manager of our London office. Yeah. And we have 2 people working underneath him. One in particular, who's a very experienced associate in sustainability issues, who has developed this tool with an assistant. We look for research work in every project that we do. We are always looking we're always looking for research and innovation that we can build our knowledge around.
Does the client fund that separately, or is that part of your overall process anyway? I mean, do you expect?
Well, we sometimes we manage to persuade clients that here is something that deserves a little bit of extra money in the fees. Right. Sometimes we are using in a way we're using cheap labor, because we're helping PhD students fund their PhDs and develop the work with us. So that's it. And the other way in which we fund this is through the tax system, I have to say, because actually anything that you do that is research, genuine research, that belongs more to the body of knowledge rather than a specific project, is a tax break in the UK.
Yeah. We have a similar thing in Turkey now, which is a status for a design office called the Design Center, through which we get tax breaks if we do research. So I'm very glad that Turkey is also, as a government, helping to do that. Anyway, let's continue. I think you finished the first part.
The first part. Shall we go on to the next part? I'll share the screen again, see if it works, see how we get on.
Next part is more project-based, isn't it? We're going to go into your projects now.
Yes.
Except that hold on, that's the wrong one. Now I'm sharing the wrong screen with you. I'm going to stop sharing because sorry, because of that I'm going to have to open the PowerPoint again. I'm sorry.
Yeah.
So I'll have to go to Okay, is that good?
Just slideshow mode.
Okay.
Excellent now.
Right. Sorry. So I'm going to have to go right the way through. So while I'm talking, while I'm doing this, oh, there we are. We're already there. Right. So I'm going to talk about 5 low carbon projects, which illustrates some of the thinking that we have been doing in both operational and embodied carbon. This is the oldest one of them, which I think is about 7 or 8 years old, but still one of the lowest carbon projects that we've done. Most of these, as you said early in the introduction, Selçuk, are educational projects. This happens to be a library for both the city and the University of Worcester. This is the completed building, and this is where it sits in relation to the topography. So this is an old disused railway viaduct. Just to make sure, can you see my cursor? You can, presumably.
Yes, we can see your cursor. Yeah.
Okay, fine. And this is the River Avon, and this is the university, and up here is the city centre. So our building is on a route that goes through an ugly shopping centre here and finds its way down and under the viaduct, a route between university and city centre. And it was a competition that we won with a contractor. So it was a design and build project for a contractor. And this is in fact a model of the building on the site. It's within the floodplain from this river. So most of it is elevated above the floodplain. And this was the very early sketch that we did. And this very peculiar shaped site that you can see in red, and the links that I mentioned to the university and the city, and the idea that what we're creating here is not just a university, but the developer who was our client wanted to create more than just the library, wanted to create building sites within his curtilage that could become retail or residential elements, and a new square that was part of the city. So this was a very early diagram, thinking about this being quite a radically organic shape of a building. And at the same time, we very early on were working with Max Fordham, who are one of our favorite environmental engineers, very tuned into sustainability. And we started thinking about creating the ultimate naturally ventilated building that was this kind of deep plan building in order to reduce the envelope area and therefore the heat loss, but to ensure that there was really good quality ventilation through the deep plan. And so the one thing that we had to do was to create roof ventilators which were constantly guaranteeing to exhaust air from the building, and therefore draw air in under the building, which was pre-cooled in summer and pre-warmed in winter. So this became one of the first drawings to describe the principles. It then became, this was a time when we first started working with BIM. So it was I think it was our first venture into building information modeling. And this was how it then transformed itself into the ventilation systems being the external appearance of the building, if you like. So we ended up with 7 of these pyramidal turrets. Interestingly, if you look across the river from the building, you see the seven Malvern Hills of Worcester in the distance. And what I just wanted to talk about here was how we went about things technically, working with in a very sophisticated way, both with programmers within our own office who devised this parametric model to actually pinpoint the geometries that we were working with. Also working with a really good structural engineer, a friend of ours called Neil Thomas of Atelier 1, who was an expert in timber construction, and working with Max Fordhams, who were making these roof turrets work for us in terms of natural ventilation. Another version of the model that you see where we're using these pyramidal roof sections to admit natural daylight, but with baffles to stop too much sunlight and glare, but we're also using them to draw air in through the building. And critical to the whole detailing was this section here of the top of the turret, which you can see here, where it's very simple. There's kind of windows really that open, that center pivot windows, or they open in, and there's a screen and louvers here. But because they are protected by this element of the geometry of the roof, the wind, whichever direction it's going here, is always going to guarantee an extract in terms of ventilation. They're always going to have an outward flow of air. And the problem with natural ventilated buildings is that they are quite often wind driven. And if you open a window here and you don't have this here, and the wind happens to be coming from here, it's going to screw up the ventilation system. You cannot guarantee that there is a one-way flow out of the building. And we then did a test model here. This is in a wind tunnel. This is a model, Perspex model. It's about a meter across here. So and we're fitted with sensors, and that's in a wind tunnel at the University of Cardiff, just making sure, allowing us to make sure that this is going to work as a natural ventilating system. Then I'm skipping to the construction phase of this building. So I'm just showing you a few isolated slides throughout it. It was a fascinating piece of construction because the contractors, our clients, didn't want to make this out of timber to start with. They said, no, we're used to designing in steel and concrete. Now, timber, forget it. But halfway through the first stage of the process, they said, we're worried about the time it's going to take to complete this building. Is there anything you can do to suggest, can we do it quicker? And we said, well, why don't we just make it out of prefabricated timber, all of these roof structures? And so we got in touch with our engineer. We had them designed very, very swiftly with our parametric model and Neil Thomas's engineering expertise. And each one of these pyramids came and was erected, it was completed within a week. Extremely fine detailing of cross-laminated timber panels. I don't know whether I've got I'm sorry, I thought I had, oh yes, there, sorry, I can't see it because the screens are covering it up, but you can see on the right-hand side of your screens, you'll be able to see one of these panels being lowered into place. They typically come about 3 meters by as long as you can carry them on a truck. So it's a production line that just produces extremely tough, structurally sound roof panels, insulated roof panels. And the timber is what you see on the inside as well. So it's the entire prefabricated panel that you see there. And the contractor fell in love with this system so much that he ended up building these roof baffles here out of it. The staircases are all the risers and the treads and the balusters are all made out of cross-laminated timber, as are all these. These are then clad in an acoustical baffling.
Can I ask you a question
yeah,
about
go ahead.
ventilation? Because
Yeah.
I think that section was really important, and it is something that we're unlikely to come across anywhere in this geography, because people are very much under the impression that a sophisticated building like a library would surely need air conditioning. Would surely need filtration. At the very least, you would need filtration, wouldn't you? Because of all the pollutants and dust and so on. So explain that to us. How is it that you can convince a librarian to allow natural ventilation without any machine ventilating?
Okay. Well, this building was 8 or 10 years ago when we were completely convinced that natural ventilation was the best low energy solution. I have to say, if we were approaching this now, we might well have a mixed mode system. We might have, for wintertime use, we might have a heat reclaim ventilation system as well as this. But we've always believed that people like to open windows in buildings in the UK. Of course, I have to say, you know, you're in a very different climate to ours. I mean, we don't really have a cooling problem at all and we shouldn't have a cooling problem in any of our buildings in the UK. If we build glass skyscrapers, we generate a cooling problem. And to go back to the other issue of air pollution, you'll have seen from the images that I showed you at the beginning, there is a beautiful landscape next to the building, which is the main source of air that's not coming through windows. This is a landscape. It's the field basically, and the air that comes into the center of the building here is drawn in without any pollutants from vehicles, etc., or urban environments. So we are lucky.
Moisture? What about dampness? I mean, books are sensitive to
heat. It's just warm. You bring in the air and you warm it as it comes in.
And
yeah.
That's it. Yeah.
Yeah, you do. There is a heating load. There's a minor heating load here, and we use a water source heat pump. The heat comes from the river. And in winter, we also supplement that with biomass heating, which is using timber as waste timber as a resource. So it's. I'll show you there's one slide at the end which shows you how it is performing.
Okay.
I have to say, this is perhaps the best performing building we've ever done.
Right.
Which surprises me in some respects, exactly what you've said, Selçuk. The natural tendency is to think, well, we ought to be able to do better if we actually control the outflow of heat. But we spent 20 years learning about natural ventilation, and this was the best natural ventilation building we did. I'm not saying it's going to be the last one, but I think we have probably, because we're tightening up everything even further in terms of operational carbon emissions, we probably are moving towards sealing buildings and reclaiming heat, etc. Most of the later buildings I'll show you are of that nature.
Right. Thank you.
So here we are. This is it. The language. This is the building, the real building it's setting, and you see here is the little island that this is where the air is drawn in underneath there to the center of the building. And although there's a car park here, there are no moving cars. So this is actually quite an unpolluted area of the city. And these are the two bits of the site that I mentioned at the beginning that have not yet been built on. They're still waiting for perhaps a bit of upsurge in the local economy to build something there to create the new little urban square at the back that is the entrance. But it's a building. They wanted a landmark building. They wanted a building that was emblematic of the city. And the interesting thing for us is that what Worcester is known for is its porcelain. And Worcester porcelain quite often has gold leaf, masses of gold leaf on it. So we picked up on that idea, and this is using copper. It's copper, it's a natural copper cladding, but it's patinated, it's a gold patination on it. I was a bit worried about it. And when I look at these photographs, I still am slightly. It is muted quite a lot in the last 10 years. This was taken, or maybe 8 years ago. So, but it's what I like about the building is it's a kind of piece of urban topography. It's a kind of crystalline form that sits there that just breathes naturally.
A literal urban landscape, as it
sorry?
Almost a literal urban.
A literal urban landscape, yes. And you can't quite see the Malvern Hills, but these are the beginnings of them over here that it refers to.
The material is beautiful.
The material is beautiful. It's also interesting. We'll come along to talk about this in a bit more detail, but it's one of the materials that we really like for cladding buildings is copper, because it is now 95% recycled. There are about 4 copper mines in the world, and they don't produce that much copper because we're very, very good at recycling copper. And it's also relatively, and which means, of course, its embodied energy is quite low, because whenever one digs stuff up from the earth and processes ore into metal, it's a very expensive process. But when you're recycling metal, it's much, much lower carbon. So, and that's the bridge that goes across the road to the city. And that's the interior. So interior is all warmth and wood and has a sort of slightly Scandinavian feel. Exterior, slightly blingy copper. And this is the way it operates in terms of measured and design targets and measured use. So we're very concerned about water usage in the UK generally, and it's not doing as well as its targets in terms of the percentage of rainwater use is not quite as much as it should have been, and the water use per occupant that it is more than it should have been. But then the building is so successful, it's been occupied 18 hours a day rather than 12, and so there's more water usage. But interestingly, if you look at the design targets for heat, we're doing much better than that with the biomass generated heat, and that includes also the heat from the river source heat pump. Fossil fuel usage is absolutely minimal. This is just the kind of ultimate backup if the river heating and the biomass doesn't quite work. So there's a little bit of gas heating in there. And electrical usage, you can see the targets was way out here, and we're less than half of the electrical target. But I have to say, and this is an interesting point, and I very freely admit to it, it wasn't working so well until we went back after 2 years and looked at the way it was working. So Max Fordhams and ourselves went and analyzed the building after 2 years of use. And we were able to tweak the control systems, replace some of the bulbs with low energy bulbs with LED bulbs that weren't fully operational at that time. And we managed to tighten up the energy performance in between year 2 and 3 of the building's operation. And it's
because of the roof light. I mean, is the fact that your electricity is so low, does that happen because you have so much natural light?
Natural light is very important, though I have to say these days this was built about the time when LEDs were becoming very reliable and very popular. And LED technology for lighting has transformed the way we think about daylighting and about artificial lighting in buildings, because we used to be totally focused on optimizing daylight. And now, of course, we're all using light. I mean, our form of light is from the screens that we look at, isn't it, really, in a workplace environment? And we don't want much natural light in our buildings, really. We want as much natural light as is healthy for us, and to provide us with a view from our buildings. So it's health, and daylighting for me now is a health and well-being issue. It's less of an energy issue. Lots of interesting things to debate. And we liked I suppose the sculptural quality of this building. I really like.
Oh, it's beautiful. So
now the next project is something that hasn't been built yet, but has just got planning permission. We're hoping to go on site next year. It's a project called Old Paradise Street, London, and it's a site. You can see the building in its site here. This is this greenish ceramic tiled building here, just on the main line trains that go into Waterloo here, and you can see our Houses of Parliament here, and some of you will recognise London Eye. So it's very mumuch central London. It's a very peculiar trapezoidal site, and it's just between a park over here and a railway. So and then the street goes underneath the railway here. And it's a commercial development for an adventurous developer who was very interested in doing something in terms of super low carbon design. And they were really taken aback here after you asked us about the people that work on the research side. And we had one particular guy who's an associate who talks so passionately about carbon in architecture and carbon in materials that he was able to convince them of that doing a precedent low energy design, low carbon design on this site was really important. So here we are, the view from the train, which is at level 3 of the building, a zone where all the people who work in the upper 3 floors and the floor below will gather as a sort of communal workspace. And what we've been thinking about the way, and our clients have been thinking about the way this will operate post-COVID. And I think it's very interesting that workspaces in the city are going to become very different spaces. I mean, we have a very large, well, fairly large office in London, as you know, Selçuk, and there's nobody in it at the moment. And we're kind of thinking about it becoming, instead of an office, we're thinking of christening it as a meeting room. You know, it's a space to meet when you need to meet, with over a design table, or around a model making workshop. But I think a lot of people will continue to work from their home environments. And I think the offices will become much more social meeting spaces. So this, we think, is quite resilient in terms of, it was designed pre-COVID, it'll be built post-COVID. And so there you see, it's a green building in literally as well as everything else, and it sits between the park to one side. There you can see the upper level is meeting room spaces, and the lower level is probably something like a kind of fab lab space, a fabrication laboratory. Again, communal facilities that could be used by anybody in the building. And that is the very narrow part of the elevation that comes out to the street, with the railway on the left-hand side. This is kind of like the fab lab space, the fabrication and materials space, and the library space, and on the lower ground floor, looking out to the railway arches. This is a site plan there, so you're looking on the railway embankment is on one side and the park on the other. Sorry, the ground floor plan, the second floor plan, which is this big open space, meeting room space for everybody in the building. And then a typical unfitted out floor plate upstairs, up above, 9-meter floor to window. So you do get good view windows, but you would get plenty of daylight if you really wanted it. But we're more concerned here about letting too much light into the building, because it's actually, if we let too much sunlight in, we create a heating load for ourselves. Elevations, another view of this, the kind of low-tech meeting room space with all its mechanical ventilation systems on show. And this, just going back, I'll just show you this as a little flash of the way we use the carbon, FCBS carbon, to calculate operational energy load. So we're doing pretty well here. You know, we're pretty much close to this sort of pioneering element of the chart. And because the whole of the structure of this building is timber, which of course I didn't mention, I haven't mentioned yet, but I'm mentioning it now, the embodied carbon is incredibly low. It is, and if you look at this bar chart here, this is the 0 line. All of these figures here are the elements of the structure of the building, which is sequestering CO2, right? Are you with me? So when you build with timber, you're sequestering carbon.
Can I just tell the audience what sequestering means? It's quite an unusual word.
Yeah, well, okay, so it's basically, yeah, okay. So it is, so when a tree grows, it soaks up carbon dioxide. When you use the timber, and as long as you replant the tree, so in a manageable, sustainable forestry system, you're replanting, so the tree is growing again. So when you use that timber, you are using, you're using a timber that has, for your building's purposes, got negative carbon. So it goes below the line here. Whereas if it was concrete and steel, but concrete in particular has got huge amounts of carbon embodied within it. So if these two elements, which are the superstructure and the upper floors are all timber in this situation, and the external walls. So everything is timber. And if this was concrete and steel, all of this stuff would be above the line, and the embodied carbon would be way down here. Really, be very poor.
Thank you.
Okay.
Thanks.
And so the lifetime carbon, again, what we're doing is we're putting so the sequestered carbon is below the line. So this building, I think I've got another. Yes, here we are. So if this building, when it's first built, instead of this building be representing a huge amount of embodied carbon, it's actually a negative amount of carbon, right? So it's below the line. This is zero here. This is the zero line, sorry, here, right? So for the first 52 years of this building's existence, it's a net zero carbon building. Now there's no energy generation on site, but obviously it's starting out here from this negative figure, and it's gradually using energy year by year as on an ongoing basis in terms of operational carbon. And the reason
what's the lifetime of the building, do you think? How long will this
well,
building?
we've said here, we've taken it up to 100 years. In terms of the lifetime of the timber, there's absolutely no reason why unless there's water ingress, you're not going to get conditions for rot. So there are timber buildings that are in existence, as you know, in Scandinavia in particular, that go back 700 or 800 years. So there is no real problem.
Yeah.
But it's so basically it starts out life as a carbon negative building, and for the first 50, and of course, the reason that this gradually tails off is that our anticipation is that looking to the future, we will find that there is less carbon in the electrical systems of that we operate. That there is the grid will be decarbonized, the electricity grid will be decarbonized. So the crucial thing is to make sure that we're not using carbon for the first 15 or 20 years, because if we do, then we are doomed. I mean, it really is serious. So that's that building. Oh, and this is just an interesting, sorry, apologies for the figures, but I'm quite interested in all this stuff. So this is comparing the conventional building, which had a concrete deck and steel beams, concrete planks on glulam beams, cross-laminated timber on steel beams, and cross-laminated planks. And you can see these are all negative figures. These are all positive figures. So it's using a lot of carbon to produce concrete and steel building, and it's negative carbon producing the cross-laminated timber. And we're also looking here at what the best options are for cladding the building. And the best option, again, from a carbon perspective, is timber, followed by curtain walling, followed by a stone rain screen. But we wanted to use, in this case, ceramic tiles, which is quite a high carbon material. I'm sorry, because I know that Turkey produces lots and lots of ceramic tiles.
One of our sponsors, actually,
our
main sponsor is Vitra.
Vitra. Okay, well, Vitra. I mean, we use a lot. I don't know whether this is Vitra tiles, but we like Vitra products and we like their ceramic products. But we are aware that just as the brick industry in the UK is looking very seriously at the carbon cost of its materials, we think and we hope, I'm sure that Vitra are looking at the carbon cost.
No, Vitra are actually working very hard on increasing the sustainability of all of their product lines. And
Absolutely.
I'm sure they can give us a whole lecture on that. They are doing a lot in that area.
Yeah.
But I will ask you an inevitable question here. You've done this beautiful comparison for concrete to CLT and so on. But a lot of the time, especially in this country, a lot of people say, well, surely it's going to be just too expensive. I won't be able to persuade my client to use timber. But also timber, I mean, they think it's going to fall down in a few years' time, So I won't be able to persuade them. So persuade me, sir. How would I?
Okay, so the two things. One is on cost, right? So we've now done about half a dozen cross-laminated timber buildings, about 6 cross-laminated timber buildings. 3 of those, we were approached by our client as the contractor, who said, can we do this in CLT because it's going to be cheaper, because it's going to be quicker, right? So that's one thing. So it's obviously not necessarily more expensive. Although where we are on the edge of Europe, and all the cross-laminated timber we get is from either Austria or Germany or Sweden.
Mhm.
And a lot depends on the exchange rates, and a lot depends on the production cycles of those. They're very, very sophisticated production cycles of those manufacturing organizations. So the cost can go up and down according to what the market is doing.
Yeah.
And I'm aware, you know, I mean, I guess Turkey probably doesn't have much timber, but I may be wrong.
Well,
but,
Turkey is historically a timber manufacturing country, but for the last 100 years, it's fallen off the edge of the earth in that sense. It has completely forgotten that. And one of our efforts is to actually bring that back. Next year, we are going to be organizing a symposium on the subject with the Swedish Institute, and I mentioned it to you already.
Yes,
but in Turkey, people are very reticent about timber, not necessarily for the cost side of it, but more because of the safety issue. They worry about fire and earthquake.
Okay, so this is something that you do need to. Obviously, both of those are issues that you need to face up to. We haven't designed a timber building in an earthquake zone, I don't think. But what I can tell you is that actually well, I'll show you one building where we're using, the only timber that we're using is actually in the floor structures. So the frames are all concrete, but the timber is in the floor, and there's a huge saving there, even if you just use the flooring as timber rather than. So that will come onto that in a minute. But I agree with you. Fire is particularly in the UK. We have had a fire tragedy that in a couple of years ago that has caused us to question lots of things about buildings. But there was a famous, you may have heard of it, a disaster in central London where a lot of people lost their lives, and the problem there was not anything to do with timber. It was the fact that it was oil-based insulants that we used that spread the fire through that building. So let's go on. Another how are we doing for time? Because I've got 3 more to do, so I'll go through them fairly quickly. Okay, Selçuk. So this is a little housing scheme for the King's College, Cambridge University, and it's this is an image of it, and it's this is the site, beautiful suburbs of Cambridge. And the brief to us was design a new college community, 24 fellows, family apartments, graduate rooms, passive house certification. So clients are coming to us now and saying, we want passive house buildings, super low energy design buildings, 100-year design life. We want this to last 100 years. And interestingly there, it is donor funded with rental income provided by bursaries for low income students. So it's an intelligent client who is coming in and saying, I want to do an exemplar building. Very lucky, we are.
Very lucky, yes.
This is the site. It's got some existing buildings on. They were quite nice buildings in a way from the 1930s, but falling to pieces. So we are actually recycling all the materials from them, including these really nice green ceramic tiles. And we were asked, it was a very, very, it's a conservation area. Cambridge city planners are very difficult to deal with. And they said they wanted pitched roofs, gable frontages onto the street. All of these were fixed for us by the planning guidelines, etc. So these are the buildings that we demolished. We retained the trees, retained one of the buildings for reuse. And what we built is this, just one of these little drawings that came to me just, and you know, I've never done anything like looks like this before, but it's a little plan drawing. It looks like a little champagne cork upside down or something, you know, and it's it just seemed a nice idea to create the gables onto the street and to create a space that opened up towards the back. And these three crescent shapes that enclose not a quadrilateral, it's a triangular quad, I suppose. And that does nice things, interesting things to the perspectives. And this is how we, the blue are the fellows rooms and family apartments. And the rest are graduate rooms, and the common room is in pink. And entrance, it's a very straightforward, run through it very quickly, working with some really nice landscape architects on this project. And the first little model that we did of the shapes of the building, and the density here you see of the walls, the wall thicknesses that you need to work with are interesting here when you're looking at very, very high levels of insulation of passive house design. So here you can see very straightforwardly, got two staircases, two apartments off each staircase here, and three levels of apartments, and then entrances here, and a group of apartments around a south-facing common room here, and another group of apartments around a south-facing common room here. In fact, there are doors here that you can close to, so that operates as a unit and that operates as a unit. Very, very simple. And we did this little model which was exhibited at the Royal Academy last year, and you can see how it's working. So the mirror in between the two is, if you look at it at one side, you see the innards of the building, which are all cross-laminated timber. And if you go to the other side, you see the clay modeled outside of the building, which is clay bricks and clay tiles, and very traditional Cambridge materials, really. It's a very vernacular building, which we quite like. But you see here the wall thickness. So working from the outside, we have brickwork, cavity, to 300 millimeters of insulation, cross-laminated timber, another layer of insulation, and vapor barrier, and the zone for servicing. So very, very thick walls. And again, the structure, the cross-laminated timber of the structure more than compensates for all of the foundations, facade, and roof, internal fit out and finishing. So everything it starts out life as a carbon negative material. And this is looking at only the operational energy over 100 years. And again, you're gradually, whilst we still have high carbon electricity, it's expensive to run, but one assumes that as the carbon disappears from the electrical system, it will even off. And this is looking at BREEAM Excellent, both the unregulated loads and the regulated loads. And this has passive house, which is the super low energy construction system that we're working to. And just a little bit about the building context and character. It's basically built around a response to the arts and crafts character of a lot of local buildings in Cambridge. This is Voysey, just in the 1920s, just down the road. This is the King's College buildings in the middle of town in about 1890. We threw this in because we love the work of Michel de Klerk in Amsterdam, doing extraordinary things with brick and tile. And there is a vernacular, beautiful use of very ordinary materials, and also curved terraces, interestingly, in Cambridge. And we kind of started thinking about both convex and concave facades, and what happens when you start bending something. If you can see my hands, it stretches on one side and it compresses on the other. And some little sketches that we did, and thinking about how the horizontal stripes might form part of the concave facade, and the vertical stripes form part of the convex facade. And just some images of what it will be like. Again, this is a more detailed layer of the carbon tool, and I won't go into it in detail, but great detail. But we are meeting the RIBA 2030 challenge. This is the 4 screens that you get from having done your exercise there, and you see here the the negative carbon of the sequestered carbon of the superstructure of the building. There are a few photovoltaics on this building, but they're generally on the cycle storage spaces outside the building. And we need very, very little operational, very, very little energy to operate the building. It's all ground source heat pumps and photovoltaic electrical.
Well, you've insulated it to death, so you shouldn't.
We've insulated, yeah, absolutely. Yeah, absolutely.
Yeah.
Absolutely. Heated by the people and their computers working away inside.
Yes. So it looks to me like the most important thing about the passive house certification is that the building is extremely weathertight and highly insulated.
Airtight, very highly insulated. 15 kilowatt hours per square meter per year maximum, very, very low. And relatively small windows, you see here, that are inset.
Yeah.
And the brickwork, I forgot to mention, the little bits of striped brickwork are air intake. Every now and then where it passes by this zone of windows here, there's an air intake here that feeds. Here we do have a little mechanical ventilation system with heat recovery, 95% heat recovery. So every room in every house is mechanically ventilated. But if you want to open the windows, you can.
So what happens when one opens the window? Does it throw a lot out of balance, or does it get?
It can do, and that's something that you have to. You can either alarm the system so that it tells you you shouldn't be opening the window. You've seen that sometimes on cars. Close the window because you've got the air conditioning on, or you can just rely on people saying, well, it's a bit stupid to open the window in the middle of winter when I've got a very, very well ventilated building that is, then the ventilation is coming through the mechanical system. Okay, so that's the Cambridge students lounging on the lawn.
Looking very happy.
Looking very happy, and the streetscape and the way it fits into this, the building on the right-hand side is an existing 1890s multicolored stone and brick building here, and this is our element next to it that I forgot to mention, and then two other gables, and then the rest of the street. So it's elegant, sits elegantly in the street.
But it's interesting. Feilden Clegg as a practice, I think, has very flexible design palette in many ways. You can stretch to a very seemingly high tech and also, volumetrically complex structure. And then on the other extreme end is very much vernacular, related to context, etc. Does that come from how the groups are divided in the office, where there's somebody who just loves vernacular and there are others who don't and want to do extremely modern buildings, or is that a practice philosophy that actually?
Okay, well, no, it's a very, very interesting question, Selçuk. I mean, I think, as you probably know, our practice philosophy is based on our social values and our environmental values. And that's then open to interpretation, and it gets interpreted in very pluralistic ways by some really good designers who are, continue to follow their own ideas. So we do get, I've worked very closely with this one, with one of my younger partners, and it's very interesting. It's become, in a way, oh gosh, what should one say? I have a love of the vernacular, and this has become slightly, it's become a modernist vernacular building. It's become a sort of David Chipperfield building in some ways, and I use that as a very nice, I think Chipperfield's work is absolutely amazing. And that influence has come through the other partner that's working with me on it. So, we are, we share design leadership across quite a few architects. Yeah. So
it's a practice which has a pluralistic approach to style in that sense. You're not saying
style, but not to the more fundamental issues of which are the social aspects of architecture and the environmental aspects of architecture.
That's the bottom line.
That's the bottom line, and you don't go outside those. Otherwise, the senior partners will be at you. So, you know, this is what creating communal, convivial space is about, isn't it, really? And using architecture to do that. And this is a beautiful bit of rendering that was done actually Christmas last year. This has been delayed by COVID, but it's now on site, this building. And we are using this building. We're constantly monitoring its embodied carbon as the materials get delivered to site. So we're using it as a real test case, this. And we found that we can do even better than those predictions in terms of embodied carbon, particularly in the cross-laminated timber, interestingly. We had put down more carbon costs for bringing the timber from Austria, in this case, than will be the case. So interesting to do that sort of degree of monitoring. So that's that one. We've got two more, are we okay? Yep. This one I'll go through very swiftly because
we're okay for time. We have like half an hour of the official time, but we can also run over a bit if we want.
Okay, all right. So this is a building that we won during COVID. It was one of those, you know, extraordinary interviews that you have to do these days with on Zoom. But fortunately, we had a really interesting client with an interesting architectural advisor who helped, I think, perhaps steering the client a little bit. And this is a building that's for the University of Portsmouth. And they wanted the brief. I think the brief is probably slightly pre-COVID, and maybe they maybe wouldn't get this brief now. I don't know, but it's the big dominant. They wanted a landmark building, confident landmark building on the edge of a park, at the edge of their campus. And this was the building that we gave them. So basically, it's as with a lot of our sites, it seems there's a train going along here. This goes to Portsmouth Harbour, and there's a major road here. And our triangular site here sits between the campus, which is here, access under the railway, and a park here. Lots of it never occurred to me that there are so many common themes. Like this site could be the Worcester site, couldn't it, in a way?
You seem to like railway lines.
Well, people give us railway lines to build up against. You will recall we had to build a recording studio for Peter Gabriel 50 yards from the biggest railway in England. So it had to be, it was a small footprint site. It had to be a tall building. We kept it as low as we could. We filled the whole site. We felt that it was a building you should see through, both when you're sitting in the park to see the sunlight coming through it, and also this podium level that we created would look out both to the park and the city, and obviously the sea in the end. So this is how it sits in its site, adjacent to a park, and these are all the university buildings, the railway and the road. Also, so this is a faculty for social sciences and business and language, I think. So, but it was basically, it's one of these it's a new faculty building that where they could move any faculty into these. So it's very, very flexible space, but it sits on a base of teaching accommodation, big lecture theatres, and then there's an administrative zone, then the faculties above, and then a rooftop event space where the Vice Chancellor can invite a lot of worthy people with a lot of money to contribute to the university. And down below a kind of market hall space that is social learning space and cafeterias, etc. That gets translated into this, where you're beginning to see here these layers of 3 big lecture theatres, an administrative zone, and the faculty zones that rise up with staircases each side. There we are, sorry, it's a much clearer diagram of the section of the building. Lots of our buildings are designed in section. And of course, it is section of the section. When you design the section, you design the structure of the building, which gets you to understand the materiality of it. And then we drilled this hole right the way through it. So that gives you 2 rooms in the sky, one for each faculty. and a central atrium space that links both faculties and the administrative zone on the ground floor. Some big lecture theatres below and the market hall space below. So it's a pretty substantial building. And the two things that make this, I think, interesting from a carbon perspective are, firstly, that its outer skin responds to the sunlight and daylight, not because things are moving, but the amount of glazing and the shading that is formed on the outside of the building by the cladding system transforms as you go around the building. And the other thing is it was designed with again trying to incorporate as much timber as possible in the building. And even though we've just ended up with the timber floors, I'll skip through that one because we haven't got much time. But it is interesting in operational energy terms. We've gone from a typical building. We're saving something like 65% of the operational carbon of the building by intelligent design. But this is, again, sorry for the graph, but this is looking at, it's one of these graphs which then looks at the 0 to 60-year lifetime of the building. So here we are, it's an enormous building, so its carbon cost we cannot get below 0. But these are just various options here. So this is looking at typical concrete floor planks and a recycled steel frame. And so let's just focus on this, which is the embodied carbon of the building as it starts. This is the operational carbon as it's added to it. But this is, if we built the building with steel and concrete, it would have it'd be almost 15,000 tons of CO2. If we went to hollow core planks with a 90% recycled frame, we can actually, this is just the recycling of the steel, we can get down quite a lot, really. If we go down to a cross-laminated timber, but we don't take into account the sequestration of the carbon in the timber, nevertheless, we then get it down to about a third of what it was with the baseline case. If you take into account the sequestration of carbon in timber, you're down to an 80% reduction from the baseline. That is just by omitting the concrete floors and putting in timber floors. And that's in every other way. It's got a good form, what they call form factor, because it's quite a deep plan building. The envelope to floor plate ratio is very good. It's a ground source heat pump, so it's really, really low carbon operational energy. But that moved in embodied carbon of the floor plates is the most important one. So that's that. Shall I go straight on?
Yeah, no, I just wanted to ask a very quick question. So is this issue coming up very frequently for you these days, whereby you do a kind of hybrid system? Yes. Is that coming up a lot? So you do.
Yes, it is, and it goes back to your question about how you build in a zone of what do you call it? Earthquake zone. Sorry. Yes. Yeah. And I think you would probably have to build in concrete. You have to build a concrete frame in Turkey, probably, wouldn't you? Or maybe not.
I said this the other day as well. There is a 350-meter tall timber skyscraper being planned in Japan, in Tokyo.
Yes, yeah.
You've heard of it. I think
which is an earthquake zone. Yeah.
Very much an earthquake zone.
Yeah.
But what this reminds me of is actually the way cars are going, where cars have this hybrid hybrid nature to them. You have both petrol and gas and also electricity. This is a bit like that, where you have an infrastructure of either steel or concrete and then timber to do the floors. That seems very sensible.
Yeah.
Very easy to transport such materials as well. So it actually makes sense. Quite.
Yep. A lot of flexibility as well.
Yeah.
Okay, I'll end with this, which is one of the more interesting projects that we started it about sort of 5 or 6 years ago, I suppose, and it's now still on site. It's taken a long time to come to fruition, but when it does, it'll be a fabulous building done for a fabulous client. And I'll whiz through these. Excuse me. You will have heard probably, I hope, of the Aga Khan. You'll have heard of the charitable work that the Aga Khan Foundation does. And the Aga Khan Academies, my understanding is that the Aga Khan has a vision to look at you could characterize them as maybe something like the 20 poorest countries in the world, and to say we want to create academies, schools in these countries that will produce the next generation of political, social leaders in those countries. I mean, it's a very worthy organization, and they have they're currently operating academies in East Africa, here in Tanzania, and I can't remember where, Dar es Salaam, and various places. One was planned in Syria, then unfortunately it's gone on hold for obvious reasons. We looked at one in Bishkek here, but we're working on the one in Dhaka. And this is it. And this is a model that we did fairly early on. And it's a very, very tight site. But just to look at again, thinking about the mantra of the Aga Khan Foundation, I mean, they take the Sustainable Development Goals, the UN Sustainable Development Goals, and they say, well, so how are we contributing to meeting these? And the most important things for them are to think about economic growth, gender equality, quality education, number 4 there being really important, health and well-being, sustainable cities and communities. They take these as really serious guidelines for them to develop ideas in. So Bangladesh is it's a monsoon climate. It belongs to that sort of strip of climates, the subtropical climates that go through Africa, South America, and Southeast Asia. And we're building in a city that is currently about number 4 or 5 in the world in terms of population. And within 5 years, we'll be number 1 in terms of the size of the city, population size of the city, and it will stay that way probably for the next 10 years. That's what the UN predictions are. This is such a huge city because Bangladesh doesn't have very big second and third cities, so everybody swarms to this one. And it's a tiny site by comparison to all the other sites that the academies, the Aga Khan have. And it's in an area, it's in Bashundura residential area, but it's now being developed at a hugely phenomenal rate with big educational facilities and big workplace facilities and factories. Everything is going on there, and it's close to the international airport. So we were asked to look at how to develop a high density school, really. You know, how high can you go with what's a 10-story school look like? Because they wanted to keep the open space, the playing fields, the landscape as part of the environment of the school. So we looked at various different options, and we came up with something that was a kind of medium density school. And this is what it looks like. Actually, this is what it looked like 2014. But this is what it will look like in 2025. And I can tell you a lot of these buildings around here have already been built. So, but you'll see this is the important thing for them, is to create this open space, this oasis. And this was, I should have said to start with, we're working with an amazing Bangladeshi architect here called Rafiq Azam, whose practice is called Shatoto. And Rafiq is a poet and an architect and a fantastic character, and he's been a joy to work with. And we have shared this work between us, the master planning and the both the residential aspects, because it is a residential school and there are teachers living on the site as well. And so it's a piece of city, really. It'll have about 1,000 children when it's finished. And the important thing for Rafiq, as for ourselves, is it goes back to the biodiversity crisis that we started the discussion about, keeping a green lung in the city. So that was Rafiq's drawing, and this is my drawing. My drawing was thinking about the 4 characteristics of education that go back to a very famous English educationalist in the 1960s, who wrote an educational report for the government, and talked about the moral, spiritual, physical, and intellectual aspects of education, which had to be embodied in every school. And here, so it kind of works in a sense, because this is the Jamakhana, the mosque is down here. So this is in a way the spiritual end of the school. And this was supposed to be, it was at this stage, one stage going to be the little nursery building. The physical aspects are taken care of by the sports science, the sports facilities and the dining hall. The intellectual aspects are the heart of learning, and the moral guidance came from the teachers' accommodation and the fact that they were living there in large family units, so providing the kind of moral welfare of the children. So that was the diagram all around the idea of the Maidan, the open space, and the academy presence, which then developed around 2 sides of the building, and the residencies mainly on the 3rd side. And, we think, we come from, in England, we kind of think that we invented education. We're so arrogant, but this is the first university in the world. This is Nalanda, which is a Buddhist university in Bengal. 300 AD. It was a kind of Buddhist monastery, but it was a space. It was really a place for learning. And this is another. I can't remember how you pronounce that one, but it's a ancient piece of archaeology, really, that was a university building, thousands of years old. Hundreds of years before Oxford and Cambridge. And of course, if you go to Bangladesh, there are, one of my colleagues went to Bangladesh and was crossing a major highway, urban highway, and in the middle of the 6 lanes each side, there was a big wide open space, and there were children sitting under a tree being taught. And that was a school, and Lucan has this amazing diagram, doesn't he, of the idea that the schools started when people sat under a tree and started talking. So the trees are really important to us, and this I'll just show you a few views of this here. So this extraordinary building here has been built. It's a university building. God knows what it is, but it's really weird. It looks like something out of Star Wars. So our buildings are here we're looking, coming around here. This is the sports buildings, the academic buildings, and the dining halls, and the residence is wrapped around here, and then the main academic buildings are here. So this bit of it is kind of almost finished now, and theoretically they will build something of this height here, which causes the transformational change of that height of building is amazing. But we feel that it's very important for us for the buildings here and the spaces here to have a real human scale to them. And Dhaka has its traditions, obviously. Lucan was there and built these extraordinary buildings adjacent to the Parliament building. These are jali screens made out of brickwork. And this is what our building will look like from the road. It's really, we sold it to His Royal Highness, the Aga Khan, saying that it was going to be an exercise in brickwork, a child's exercise in brickwork, an exemplar story of how brickwork could be used in all kinds of different ways. We did a full-scale mock-up for testing design quality, the quality of the brickwork, and what precision we could get, and how we use it for training some bricklayers. So these are examples of the different kind of screen brickwork that we will use in the building. And this is a training scheme that we're developing for bricklaying. And this was part of the, there is a concrete what do we call it? A walkway that goes all the way around the Maidan that provides shelter from rain and sun, and provides a network under its floor plates of service distribution. And then beyond that this is again part of the mock-up building. So it was showing us, exploring how to build this really. And then this is the real building emerging. We also were able to, within the mock-up, we were able to do some testing of the impact of the thermal mass of the interior of the building. So here we have external temperatures doing this in Bangladesh on a diurnal setting, and internal temperatures doing this. So this is a purely naturally ventilated solution. So we're peak lopping here about 6 degrees of heat. And then the visuals, which are done by our partner architect in Bangladesh, actually doing extraordinary modeling with the scheme. Sunlight coming in from the east to welcome the children coming in that direction, and the concrete script, a cast concrete script on the right-hand side. Ventilation chimneys, which actually I have to say haven't survived the value engineering exercise, and we actually end up with there was a connecting duct here that goes back to a mechanical ventilation system, which is a great shame. But and courtyards and more courtyards that were designed to take flooding, to take the flash flooding that you get with monsoons. So this was just to show that courtyard can become, for a few hours, completely flooded, and then the water will eventually sink. And there is also a waterway on the inside of the, here we are on the inside of this covered walkway that runs right the way around the building. Cricket, inevitably, being Bangladesh, is one of the key sports. One of the exports that we gave them, I suppose, but they're much better at it than we are these days. And this is how we're building up the structure, and using lots of fan movement in both the living accommodation and the classrooms. Amazing. Bangladesh is incredible for its lush vegetation, so we're introducing that to the roof spaces as well as the courtyards. All the circulation spaces are all open, so there are no corridors in this. This school, there are only balconies. So we're not doing any conditioning in that space. We're just shading the spaces. And then we're working with our favorite landscape designers in Bath, Grant Associates, but also with Rafiq Azam from Chatoto in Bangladesh, to create a really lush landscape at the heart of this site, with different kinds of landscape spaces that can be used for teaching, for play, for, as I said earlier, for rainwater attenuation. You can see some of these are very much sunken spaces that will become flooded for a few hours, maybe a day or two in the monsoon season, and then it will dry out. But that's better than overloading the drainage system, which causes flooding at large in the city. Very, very important. And then you can see the sort of walkway that goes right the way around the Maidan there and links everything together. The nursery area, all outdoor play and learning spaces, and of course cricket and football in the center. So that's my last slide, and they're exploring the idea of imprinting onto brickwork here, which is really nice.
Beautiful. Yeah, it reminds me very much of the Louis Kahn effort to develop the brick industry when he did the parliament.
Yes.
The parliament building. So did you have to do any kind of technological support, as it were, to the brick industry to encourage them in any way, or is it already there? Is it existing?
Well, Lou did a good job. Lou did a good job, and so the industry is there, really. I mean, it's you know, that building, the Parliament building, and the residences next to it are absolutely phenomenal buildings, and they set the brick industry up, and inevitably there are. I mean, this is perhaps typical of brickwork, and you can see it's not the quality quite of that we would expect in Europe, but it has that really nice rustic character to it. Yeah. And we worked very much working with their precision, the precision that they offered us, which is less than European standards, but it does give us a really nice kind of quality.
But these are handmade, are they? As they were before?
These are handmade, yeah. These are handmade, yeah. Now but we're using machine-made bricks. We are using machine-made bricks, yeah. And of course, it's an interest. Again, it goes back to the ceramics. Brickwork is generally around the world a dirty industry. Uses lots of fossil fuels, and the brick manufacturers have to also get their act together, just as the architects have to get their act together to actually reduce the carbon content of the material. We are using in East Africa. We're doing a lot of work with ISSB, which is interlocking soil stabilized bricks, which don't have any energy going into them at all. They are sun-dried effectively, so it is possible to do that in certain parts of the world. But in the Dhaka climate with the rain, they need to be fired bricks.
Yeah.
So happy to answer any questions you have. Been really nice talking to you, Selçuk.
Thank you very much. It's been wonderful listening to you. Ece, you've been very quiet. Do you have any questions?
Yeah, thank you so much, Peter. I personally enjoyed the graphs and the calculations, so
good, great.
I'm happy to see lots and lots of it. I have a question to you, if that's okay.
Yep.
My question will be a bit about design education, and from your teaching experience for so many years. So we can see that even the environmental design education is transforming. Like even 8 years ago, when I did my environmental design masters, we were only doing kilowatt per hour conversations, like the calculations, and now we're moving into more carbon, embodied carbon is now on the table, and the new ways of calculations are coming out. And so how is that? And you were talking about how LEED and BREEAM has a long way to catch up with all these advancements.
Well, one of the things that you know, I kind of feel that in the last few years, this is my 43rd year in practice, and in the last 3 years, there has been a complete change around in terms of the younger generation at universities getting really excited by low energy design, and also a coming together of environmental design, as you have trained within environmental design and the MEP and structures, you know, and I teach at Bath University, where, as Selçuk knows, it is the course is we work with architects and structural engineers and environmental engineers in the same teaching groups. So we do projects together. And I think that is, I just think that is the best way. That's the future. I've always taught that school in that way. Selçuk went through that school in that way. And it's a liberating experience. But Steve Tompkins was saying, I was getting so excited about the new generation of environmental design. And Steve said, it's like you're an old age pensioner, you've been given Viagra. There's something really exciting about it. And the guy, sorry, that might not be understood by some of the audience here, but anyway, I do feel inspired by it, and I would recommend, if you to whoever else I'm speaking to, to check out the LETI guides. There's 2 guides that I showed you images of, which are written by young professional architects and engineers as guidelines for the future. And what they're doing, they have completely taken over from the regulatory system in this country. So now developers are coming to me and saying, well, yeah, we're working to LETI guidelines. LETI guidelines are written by 25-year-olds, which is great in a sense. They've been checked by 55-year-olds maybe, but they are, you know, they're just saying this is the future. And it's, thank God that generation, it's your generation actually, really, you know, your generation are actually saying this is the way forward. And the older buggers amongst us are following along, really. But I think things have dramatically changed. Yes. So your question was really about architectural education. I'm being constantly pushed now by my students, which is great. You know, in terms of social values and environmental values, you know, the thing that's come through this year from the Black Lives Matter has gone through the student framework in the Bath University, and it's making everybody think really hard about climate justice, which is linked to the climate emergency and the social emergencies that have come up as following that horrendous episode earlier in the year in America. So they're all interlinked, and it's great. I feel rejuvenated.
I mean, I feel the same way, actually. I think that there is a kind of re-energization going on in the last year, especially. Also because we've had time to sit down and think about it a little bit. Thank you, COVID.
Absolutely. Yes, exactly.
I've been thanking COVID for many, many things. But one of them is this, actually, that we're able to spend time. We're able to spend time and think about what the values are, what our values really should be going on, and kind of dropping off all the things that are the weight of what you've been carrying previously. Just drop them off and continue lighter, as it were, with those values that you really hold close to your heart. I just want to ask you a bit about values. I mean, because your design work, you mentioned when I asked you about style in the office, is that style is not driven, values are driven. Basically, the office has a value system which underwrites everything. It's the foundation line, as it were. And this Architects Declare movement is really mainly about that. It's about re-questioning, revisiting our value system, and questioning ourselves about what we hold to be the most important in our lives going forward. You know, how are we going to rejig our value system so that we can achieve a better life and also a healthier planet, healthier living, and so on. So I want to get back to that. And I know that the UK is quite far ahead. I mean, I appreciate that when you're talking to people in other countries, they're at different stages of developing that idea and pushing it and pursuing it. And the government or local government input will affect the success with which you can implement some of those things. But what is it that the Architects Declare process now defines as our pathway, as architects, as designers, engineers, etc.? What steps will now be taken going on from today actively? You know, what is it that architects are going to be doing actively from day to day?
Well, I think we are there really, you know, Steve Tompkins and myself and the original declarers had no idea that this would become such a popular thing. And in a sense, you could say, well, it's popular because it's so easy. All you have to do is to sign your name and then you can forget about it, you know, and there are some people who are probably doing that. But what we have found is that, you know, that we have, I think, struck a chord with architects globally. And we have also found that the conventional setup for architects, the conventional professional organizations are not necessarily delivering to the community of architects what the community of architects wants. Now, within the UK, the architecture, the RIBA is actually, in a sense, joining up with us. Initially, they said, do you want to come and run Architects Declare through the RIBA? And we said, no, we'd rather hang on to it ourselves. But we are now working with them, for instance, on an Architects Declare practice design guide. Mm-hmm. which will give kind of ideas about what you need to do. Firstly, get your own house in order running a practice. Secondly, what are the useful routes to provide continuing professional development for people working with you. Thirdly, what are the easy wins, if you like, for understanding embodied carbon, understanding renewable energy, understanding a whole range of things, questions that come up to me at all our regional Architects Declare meetings. And I think, one of the things that we did just before COVID and lockdown earlier this year was within our London office, we ran a little seminar about embodied carbon. And I have to confess, I did this because I thought, my practice doesn't know enough about it. So I want to get everybody into my office and tell me what they know about it. And I asked 10 practices whether they would send along the person in their practice who knew most about embodied carbon and give a 10 or 15 minute talk. And they all came along and they did it. And it was an amazing sharing of knowledge that we've never had before. And we also, we advertised people, we charged people because we wanted some money to help with the Architects Declare. So we charged people, I don't know, something like 20 quid or something. And we were completely oversubscribed. And we filled the whole place. So that's another thing that Architects Declare is doing. They're filling in the areas that the conventional professional organizations aren't doing. And just as the LETI guidelines are filling in, and they invented a new set of regulations that our government has failed to do. So I think there's a huge amount that we do need to do as architects. As an organization, we are just the embodiment of the signatories, really. We don't have any money. We don't have any power, but we're actually trying to raise some money because our signatories are all saying, well, what are you doing? You should be teaching us. You should be telling us what to do. We say, we haven't got any money. But we are gradually doing a little bit more on that front. And the practice design guide will be one thing, and that will be followed, I think, by retrofit design guide. So we are producing our own information.
And you're meeting regularly to.
We do meet. For me, we meet too regularly. We meet once a fortnight for 2 hours, and it's just too much in my diary. But we're also forming little subgroups. We're also, I think there will be people out here that know that we've been in the limelight recently because people say, well, we're taking on too much power, and what's this about Architects Declare saying, calling up Patrick Schumacher for questioning excessive growth or regular growth and questioning believing in future technology solving present problems. And we just made a mild statement to the press about it, and that caused a great furore. So it's an interesting dilemma for us because it's not what we are supposed to do, really. We don't have a mandate necessarily to do that, because all we are, as I say, are representatives of a group of signatories. So we're trying to find our feet in a way.
Yeah, but I mean, I think it's kind of a sign of the times that there is obviously populism has become very powerful in the last few years, and without naming names in politics, there are many who have used that kind of you know, that background basically. And I think this is also part of populism. It's a positive side of populism in the sense that population, the younger generation, led by Thunberg, who said, "We had enough." In our city in Ljubljana, where I live half my life, there are regular protests. Literally every Friday, mostly young people come out, and even during COVID time, you know, they come out and they protest about government policies that are to do with this kind of thing. They do it regularly. It has become a driving factor in the way the government will actually make policies, because individuals are coming out and saying, this is enough. You need to take control of this situation. It's running away. And at all sorts of levels, at all sorts of interesting areas. So, of course,
they are the generation that are going to have to deal with the disasters that we've created. You know, that's the thing.
Exactly. I mean, we're handing over to the next generation something which is at a tipping point.
And we have as of today, I mean, I don't know, it was an interesting, I read an article today about, published in Nature, which is, you know, one of the most authoritative journals in the world.
I saw it,
You see, and it was very interesting that the extent, the mass of man-made material in the world has this year become greater than the mass of living material in the world, which of course includes us, all the animal life, all of plant life. And there is now more material stuff that we have dug up and created than there is left in the natural world, which I find astonishing and worrying.
It's scary. It's very scary, and it's rapidly rising. Scary. I have a question, Ece, you maybe want to ask this one. There's a question on the chat line.
Question from the group. Aslı Bektaş is asking, do you find the EU policies about carbon efficient renovation of existing buildings sufficient enough for the UN 2030 target?
This is, you're talking about EU policies. It's EU policies.
Yes, EU policies.
That's what the question is.
So I think I'm not quite sure what they're referencing, but I know that the EU policies, in many respects, in terms of if this is to do with a green recovery from COVID, because certainly France and Germany and a lot of EU countries are talking about putting more money into renovation of existing buildings than the UK is. I mean, talk about, well, no, mustn't get too political, but I think our government has singly failed to invest in existing building infrastructure. Instead, they've taken the easy routes and invested in renewable energy, in offshore wind, in air source heat pumps, which is good, but we still have a building stock, existing building stock, which is very, very low quality in terms of its heat loss, etc. And I know in Europe, in continental Europe, we have to be careful. We're not going to be part of it, sadly, in a few weeks' time. But the regulations there are much tighter, and the money that is going into a green recovery and into insulating existing buildings is much greater than ours. So the question referred to the 2030 challenge, the RIBA 2030 challenge. And I think certainly the 2030 challenge, the way it's written, will, I hope, make us much more cognizant of the value of existing buildings and the carbon embodied in existing buildings. Because we're setting carbon targets for ourselves, and certainly architects declare, as a movement, as I have mentioned, is very much more keen on building renovation than building construction, new building construction,
and recycling buildings rather.
And recycling buildings, yes, and recycling materials,
Well,
Anything else?
I think we've come to the end of our allotted time and exceeded it by about 15 minutes.
Well,
but I can go on forever about this, and thank you. You can go on forever as well.
I
know.
can, unfortunately.
And hopefully there'll be other opportunities to go on forever at other times. But
well, it's been a great honor to be your, I think, am I your final speaker? Gosh.
You're the final keynote
Yes,
speaker. Tomorrow is the
well,
closing. You're the final speaker.
Oh gosh, well, I hope there's still some people there.
there are.
Well, thank you very much for inviting me. It's been really great.
Thank you for spending your time.
Peter.
And, it's of so much value to us. Thank you very much. And we will obviously there will be recordings of the whole thing, and you will be able to watch it again yourself online. Everybody on here who have missed it will also be able to watch it.
Right.
Ece, do you have any other last words, or are you okay?
No, thank you so much. And I think we're going to continue talking about Architects Declare in the upcoming days and months together.
Good.
And hopefully we're going to make more events, and hopefully we'll get a chance to have you again on board. But thank you very much for your time.
I mean, I'd like to just say that we, the Circle has been preparing the Architects Declare launch in Turkey, and it has been ready for about a year. But since the beginning of the year, as you know, certain things have happened. And I think it was very useful to hear you talk about your process, and the way in which we can somehow mirror that process here will help us in the launch in the next year, which we're hoping to do. So in January, Architects Declare will be launched here as well, and people will be able to become actively part of it. So
Great.
Peter, thank you very much for all your encouraging words, and hello to everybody back at the office, not that they're in the office, obviously, and good night. Thank you. Good night to everybody else as well. İyi geceler.
Bye-bye.
Thank
Bye.
you. Bye.